Astronomy is constantly improving and modern people learn something new about space almost every month. Scientists usually focus on objects that are billions of miles away from Earth. There are many exciting things that can be found within the solar system. I have already spoken to you about the limits of the universe and what is beyond our galaxy. Also, I will tell you about Proxima Centauri, the closest exoplanet. It's now time to look at another celestial object that is equally worthy of our attention. Sirius is the brightest star in the sky. It is often perceived as one star by most people. In reality, Sirius is actually a binary star system that consists of Sirius A and Sirius B. At a distance of about 20 astronomical units, both stars orbit their common center of gravity. This is just 1 astronomical unit less than the distance between Uranus and the Sun. Their orbital period around the center of gravity is 50 years. Sirius A, the main component, is a visible star with spectral type A1. It has long been recognized as the only star in this system. It has a radius of 71% greater than the Sun and is approximately 2 solar masses in size. Sirius A is a close object for amateur astronomers. It is located 8.6 light-years from our solar system. The star's brightness is 25 times greater than that of the Sun. This celestial object is larger than our main star in terms of its mass and dimensions. It may also have a higher temperature than the Sun, which could reach 9,940 kelvins. The object's most striking feature is its high levels of iron, which are 316% more abundant than in the Sun. The spectrum also shows that other elements heavier than helium can be found. It is possible that the star was enriched with metallic elements by nearby objects tens to millions of years ago. Sirius A's future evolution will likely continue as it is now for approximately 660 million more years. After that, it will become a red giant, then a white dwarf. Although science has only discovered a few thousand white dwarfs, this type of final state is typical for stars that are similar to our Sun in terms of both mass and dimensions. Because of their small size and low luminosity, these objects are difficult to find. Scientists estimate that the galaxy's total number is 10 billion. This is about 5% of the stars in the Milky Way. The Sirius stellar system's second component is precisely one such object, and it is also the first white dwarf to be discovered. Friedrich Bessel, a German astronomer, noticed that Sirius A's trajectory sometimes diverges from its linear motion in 1844. Bessel suggested that there was a hidden mass orbiting around the star's common center to explain this behavior. This hypothesis was met with skepticism, as if true, the mass of the hidden satellite would be equal to that of the Sun. 18 years later, in January 1862, Bessel's assumption proved to be correct. Alvin Graham Clark, an American astronomer, spotted a small star close to Sirius while testing a 46-centimeter refractor. According to Friedrich Bessel's calculations, its orbital motion corresponded with the calculations. Sirius B was given the name of the star. This white dwarf is about the same mass as the Sun and is the largest known. Despite this indicator not being representative of the celestial object's diversity, it has a volume less than 1/1,000,000th that of the Sun and dimensions nearly equal to those of Earth. The star likely completed 2 stages of star evolution before becoming a white dwarf. These were the main sequence and red giant stages. Scientists believe the star turned into a white dwarf of approximately 120 million years ago. The star's mass was 5 times the Sun's. Sirius B has a luminosity of 0.026, which is less than the Sun's, and a temperature of 25,200 kelvins. Sirius B is not heated by the Sun, so it will slowly cool down and eventually become a black dwarf. Scientists have yet to observe this type of object. The discovery of Sirius B, as well as its white dwarf status, has provided invaluable information for understanding the life cycle of stars and the various stages they go through. This star, unlike its younger neighbor, is not easily visible in the sky. Science has long ignored Sirius B. Scientists were able to see the object clearly with the Hubble telescope only on October 15, 2003. This picture shows both Sirius A and Sirius B stars. It is located in the constellation Canis Major, which is in the southern hemisphere. It is also visible to the naked eye in the northern hemisphere. Sirius is a highly visible object that has been studied for many years by humans. However, it has become shrouded in legends due to its excellent visibility. The object was known as the Nile star in ancient Egypt and was also associated with the goddess Sopdet's name since its morning rise signaled the flood of the river Sopdet during the summer solstice. The works of Roman scientists Seneca, Ptolemy, and others mention Sirius. They described the star's scarlet color. It is often referred to as a bright red star, and also has a place in the history and astronomy of Mesopotamian and Chinese astronomy. These contradictory descriptions made Sirius a notorious subject of many pseudo-scientific theories. Interstellar dust may have caused the temporary reddening of Sirius's star. This dust was able to influence the Earth and Sirius, giving the star a reddish glow. A third possible explanation is that the system may have a component whose orbital period is approximately 2,000 years. This hypothetical celestial object could make Sirius A's star turn red if it is located close to Sirius A. To date, however, no object even remotely resembling this type of object has been found. NASA launched the Transiting Exoplanet Survey satellite in April 2018 with the goal of discovering exoplanets orbiting bright stars. It is unlikely that Sirius will find any planets in its vicinity, as it is a young star. However, the satellite will gather data that will help the probe in greater detail. Although there may be at least one large planet in the system, life cannot exist there due to the fact that too much time has passed since the star's formation. Other than that, all planets in the habitable zone must be extinct when Sirius B was at its red giant stage. This means there is no chance of finding any life in this system. Modern estimates suggest that Sirius is a young system, with an age of between 200 and 300 million years. Procyon, which is 5.2 light-years away from Sirius, is the nearest star. Although the Sun is currently in 6th place, this could change in the near future. Sirius is moving at 7.6 kilometers per second through our solar system. This is why it will gradually increase its brightness. Sirius will continue to shine brightly in the sky for many thousands of years. After that, the process is expected to reverse and the star becomes ever dimmer to Earth. Some may consider astronomy to still be young science in our modern age. Most discoveries are made using state-of-the-art equipment. The movements of celestial bodies have been studied over the history of man. This is evident in the star Sirius. We value our subscribers. We only select the best science-related items. We are motivated by your support and encourage you to like our videos. Thank you to all who have supported us through Patreon. It is because of you that this project continues. We hope you enjoyed the video and will try to give you some more in the next few minutes. In conclusion, the Sirius binary system offers us a fascinating glimpse into the complexities of the universe. As our understanding of astronomy continues to grow, it is essential to remember that even well-known celestial objects like Sirius still hold mysteries waiting to be uncovered. This serves as a reminder that our quest for knowledge is ongoing, and the vastness of space offers an endless array of wonders for us to explore. This part of the universe is well explored. It's only a small part of the whole cosmos. It is impossible to predict with certainty what space objects might lurk in the depths of this galaxy, which is several million light-years from Earth. They are unlikely to be discovered for a very long time. Imagine that multiple radio signals from a distant source are simultaneously detected on Earth. They would be believed to have been emitted from an extremely advanced civilization, which is what many people believe they are. Scientists who first encountered the phenomenon of pulsars made this assumption. July 1967, Jocelyn Bell, a postgraduate at Cambridge University, detected a series of pulses using a radio telescope. The pulses came from an unknown pulsar at the time. The results of the observations were kept secret for many months. Initially, the object was called LGM-1, which stood for Little Green Men. This name was chosen because these extremely regular pulses could not be natural phenomena. Jocelyn Bell's team also discovered 3 other sources of similar signals. It took 7 years to study the phenomenon, and Jocelyn Bell's thesis advisor was later awarded a Nobel Prize for his work on the celestial body. The result was called PSRB 1919 plus 21. This pulsar was the very first to be registered. Its source would be found 2,283 light-years from Earth in the constellation Vulpecula. In February 1968, information about PSRB 1919 plus 21 became public. By 1969, 27 pulses of this type had been detected. The term pulsar was used to describe these objects. This signal was first detected by the object dubbed PP0943. Soviet astronomers spotted it in the Leo constellation. The most common assumption regarding this discovery at the time was that all pulsars were radio beacons from extraterrestrial civilizations. The pulsating signals reminded one of a lighthouse twinkling in the night. Astronomers quickly realized that regular signals are most likely the result of neutron stars. These impulses are believed to be the result of neutron stars spinning, which emit radio waves that are thin. The observer detects them at regular intervals, which is why they emit a pulsed appearance. 2008 saw the discovery of approximately 1,790 pulsars. They all produced powerful impulse radio waves in space. The closest pulsars to us are located some dozen light-years from the Sun. Astronomers discovered other sources of pulsating energy similar to the ones that were initially detected by pulsars. These sources were described as strong flares that emit X-rays intermittently and frequently. They were named X-ray pulsars. Although X-ray pulsars are highly magnetized neutron stars, unlike radio pulsars which use their own rotational energies, X-ray pulsars are powered using accretion disks. An accretion disk is made from material taken from a companion star. The latter will eventually become a white dwarf, its resources exhausted. X-ray pulsars' mass and spin rate gradually increase over the course of evolution. Radio pulsars, on the other hand, tend to slow down with time. Radio pulsars, for example, complete one rotation in a time span of several seconds to several tenths. X-ray pulsars can do hundreds of rotations in the same time frame. It is quite close to our system, and one of these celestial bodies was recently discovered. It was named J1023 plus 0038, and the source of its light caught the attention of an astronomer as early as the 21st century. Its pulses were detected by the Earth in 2017, however. This was the first ever millisecond optical pulsar to be discovered. These celestial bodies can also be called neutron stars. These pulses have a spin rate several times higher than regular pulsars due to their rotation period of 10 milliseconds. These pulses are part of binary systems. Their spin rate increases to amazing speeds due to the pulsar pulling material out of the gaseous disk produced by its companion star with a smaller mass. When a neutron star is in active accretion, it can be seen as a source of X-rays. Bright pulsed radiation can be detected in radio and gamma spectrums when the speed at which the neutron star pulls the material down is lower. Science has only discovered a few other pulsars that fluctuate between radio and X-ray spectra in this type. Scientists were able to discover this first transitional optical pulsar with such a high spin rate. J1023 plus 0038's rotation time is 1.69 milliseconds. This is 0.00169 of 1 second. The object is 4,500 light-years away. Its companion star has a mass of 0.2 times that of the Sun. The pulsar takes 4.75 hours to orbit its companion star once. Although it appears to be a neutron star, J1023 plus 0038's properties have not been fully investigated. The object was originally thought to be a radio pulsar. However, scientists discovered that its impulses were not always strong enough, and it could flare up in the X-ray spectrum. Scientists believe this may be due to the fact that the pulsar was in the middle of the phases. The process looks like the following. Radio emission occurs when material from a companion star is pulled toward the pulsar. Star wind doesn't allow material to form an accretion disk. This is why the gas does not heat up and appears brighter in the radio spectrum. The second phase is when the stream of material from J1023 plus 0038's companion becomes stronger and forms an accretion disk around the pulsar. This disk is actually the source of the visible X-ray emission. Millisecond pulsating in the optical band J1023 plus 0038 was soon detected. The swift X-ray telescope's earlier observations have shown that the neutron star was at the time surrounded by an accretion disk. The study's coordinators believed that the pulsar might have begun to flare up in the optical spectrum due to electrons in its magnetic field. This was when electron speed was very close to the light. Astrophysicists will continue to observe the binary system to better understand its processes. Now, let's move on to the object that is the furthest from us. It is NGC 5907X1. This celestial body is also one of the most bright pulsars that have been discovered. This pulsar was discovered in 2017 and is an extremely bright X-ray source. It releases nearly as much energy in one cycle as the Sun does in 3.5 years. This is quite shocking. These X-ray sources were initially thought to be black holes by earlier astrophysicists. After the discovery of NGC 5907X1, it was discovered that they could be pulsars. It is approximately 50 million light-years away from the Sun. Its spin rate is variable. In 2003, the rotation period for the pulsar was 1.43 seconds, while it fell to 1.13 seconds in 2014. To compare, if the Earth could change its rotation speed in this way, it would take only 19 hours to complete a day. The intense luminosity at NGC 5907X1 cannot be explained by modern astrophysical models, but scientists suspect it may have something to do with powerful multipolar magnetic fields that could be hidden within the pulsar. Understanding why such huge amounts of energy are being released will require more complicated studies. A few decades ago, the phenomenon of a pulsar was unimaginable. Science today is capable of distinguishing this phenomenon from any other in space. We are seeing progress in civilization, which leads us to believe that this century might reveal other phenomena not seen before. The universe is like a huge canvas with many blank spots. The pattern on the canvas changes as we learn more about space. It could soon become a full-fledged map that shows the vast universe we have explored with regular changes.